All right, one more problem where we're going to be doing trigonometry to find the value of a missing side of a right triangle. Notice this time there's two variables we need to find. The good news is that's not really going to change the process all that much. In fact, what I would do is let's not even worry about angle or side y right now. I'm just going to forget about it and focus on just finding side x first, and then we'll come back and find y at the end. So here's the angle that was given to me, so I'm going to circle that angle as my sort of reference angle to start with. Remember, never circle the 90-degree angle. If you want to find that top angle, go for it. Otherwise, I'm going to work with just this angle right here. Side 18 is my hypotenuse, the longest side across from the right angle. The other side that's labeled right now is the x side. I have to get there by walking away from the angle, making that the opposite side, so I'll label that as opposite. And the third side, that y side, would be adjacent, but we're not worrying about it right now, so let's not even label it. So I need to figure out what part of SOHCAHTOA I'm going to be using this time, because that'll tell me, SOHCAHTOA. So that'll tell me whether I'm using sine, cosine, or tangent to solve this problem. Well, it looks like I'm working with opposite and hypotenuse, so O and H. The part of SOHCAHTOA that has O and H in it is right here. So that tells me I'll be using sine to solve this problem to find the missing side x. So let's write down the sine of the angle, so sine of 32. And I'll put that over 1. Has to equal the opposite side, which is x, over the hypotenuse, which is 18. So use a trig table, or probably using your calculators to find the sine of 32. Round that to 4 decimal places. I'm getting 0.5299. If you round that differently, well, you shouldn't. It should just 0.5299. If you're not getting that, though, you might be in the wrong mode, so check that you're in degree mode, not radian mode. And then equals x over 18. At this point, I'm going to solve the proportion by cross multiplying, so 1 times x is just x. And when I cross multiply the other way, 0.5299 times 18, that'll get me the answer. So let me just do that. 18 times 0.5299. I come up with an answer of about 9.5. Depending on where you rounded, you may be a little bit off. As long as you're within the ballpark, that should be fine. So there's our answer. Don't forget, though, we had originally ignored that y. So we do have one more thing we need to do. There's a couple options at this point. We know two sides of the right triangle. So this side x we know is now 9.5. Because now we have two sides, we could go ahead and just use Pythagorean theorem if we wanted to find that third side. Most people will end up doing that. They'll do y squared plus 9.5 squared equals 18 squared. Now, the reason some people don't do that, though, is because 9.5 is a rounded answer. And to use a rounded answer to get another answer, we're kind of compounding our rounding, and our answers may not be as accurate as we want to be, but it will certainly be accurate enough for what we're doing. The other way to solve this problem was we could do another trig type problem. So let me go ahead and set up the trig part, and then you can decide which way you want to do it from there. So that I'm going to stick with that same angle, so this angle down here, but this time I'm going to ignore the x side. I have that figured out, and just worry about finding y. Well, to find y, I've got the adjacent and I've got the hypotenuse. Look at SOHCAHTOA, find the part that uses a and h, adjacent and hypotenuse, and I can see this time it's going to be the cosine part of SOHCAHTOA. So let me write that equation out, and then I'm going to just let the video kind of play through to solve those. So I'd be writing cosine this time, if I'm not doing the Pythagorean theorem method. So cosine of 32 over 1 would equal the adjacent side, now it's y, over the hypotenuse, which is still 18. So I'm going to go ahead and let the work play through. You can kind of work them out on your own. And you'll see that the two answers we get, whether we do it with this method, with the trigonometry, or do it with this method using Pythagorean theorem, both answers for y should be approximately the same thing. There you go. As you can see, no matter how we did it, either with trigonometry or Pythagorean theorem, we found that third side, the y side, to be about 15.3.